All right, we've learned how to solve systems of equations with substitution, elimination. We can even use graphing as long as it's only two of these. Unfortunately, a lot of times real life systems of equations wind up with like 5 or 6 equations with 5 or 6 variables, and substitution and elimination just get really, really gross when you wind up with that many equations. So we need a process that works better for any size system. So the process that we're going to do right now is called Gaussian elimination. Okay, and the first thing you need to know about Gaussian elimination is that it's basically elimination. It's elimination, just written in a slightly different way. So the first thing I'm going to do with Gaussian elimination is put it in standard form, just like we would with regular elimination. So I'm going to write 3x minus 10y equals 7. I'm going to write negative 5x plus 2y equals 4. It's the same equations, they're just written in standard form. Now what we're going to do, we're going to write these as an augmented matrix. Now, I'll have some students say, well, why are we doing this? This is just making things more complicated. No, it's not. Can you imagine I had like 5 different equations with 5 different variables, and I'm having to write x's and y's and z's and q's and whatever. I don't want to have to keep up with all of those letters and variable names. So what this does is it gets all the variable crud out of the way. So we're just dealing with the coefficients. And that's going to actually make it a lot simpler, especially when I shove it into a calculator, which is one of the advantages to using these methods, is that calculators can handle these really, really easily. So let's say I've got this right here. The first thing I'm going to do is so let me back up. Gaussian elimination, how it works is we're going to transform this matrix to have a 1 here and a 1 here and a. So even if we had like a whole bunch of rows, the first ones would be 1s. The first non-zero coefficients are going to be 1s. And everything below a 1 has to be a 0. May not make sense why we want a 1 here and zeros in front, but you'll see why in just a moment. So how am I allowed to change this matrix? Well, let's look back to how we would normally change things. Well, am I allowed to multiply things on both sides? Well, yeah. So I can multiply a row by anything that I want. Well, how else do we do elimination? Well, sometimes I add these together. Sometimes I even multiply this by something before I add it to this. So those are the things we're allowed to do. We can swap the equations, we can multiply the equations by things, and we can multiply an equation before we add it to another row. So my goal, again, is to get a 1. So I'm going to multiply this whole first row by 1/3. All right, now that I've done that, I'm going to eliminate this bottom guy. Now, how am I going to eliminate this -5 and turn it into a 0? Well, I'm going to take my row 1, I'm going to multiply it by +5, and then I'm going to add it to row 2. So that gives me 5, -50 thirds, 35 thirds, and I'm going to add it to -5, 2, and 4. So that gives me 0. What is this? 6 thirds. So that is -44 thirds. This is 12. So 47 thirds. So excuse my nasty fractions here. I intentionally didn't pick one with with nice numbers. So this is 0, negative 44 thirds. This is 47 thirds. All right, so I have my leading 1, and I have my 0 underneath. Now I need to turn this into a 1. So how do we do that? Well, I multiply this by its reciprocal, okay? Technically it's negative reciprocal, but so I'm going to multiply rho 2 by negative 3 over 44. Or no, I am just multiplying it by its reciprocal. Okay, so this becomes 1. So the 3's cancel out here. I get negative 47 over 44. Now, this may look gross to you, but we have good news. If I was to rewrite this as a system of equations, I would have because I have all zeros and a 1, that means that this is just y. So we've solved our y. Well, what can I do once I've solved my y? I can put my y back in and I can find my x. I'm not going to do it because we've got gross fractions here, but this is called row echelon form, where you've got nothing but leading 1s other than my zeros, and below every 1, we've got zeros. This is called row echelon form. So that's Gaussian elimination. There's also something called Gauss-Jordan elimination, which takes this one step further. Now, the way that Gauss-Jordan elimination works is instead of just having 1s with other things up here, we're going to have 1s with zeros up here. Well, how am I going to do that? Well, I'm actually almost there. What I'm going to do is I'm going to multiply row 2 by 10 over 3. And I'm going to add it to row 1. So that is so I've got 0, 10 thirds, negative 470, 130 seconds. And I'm going to add it to this guy right here. Okay. So this is 1, 0. And then let me think about what this is real quick. Okay, so I looked it up real quick, and the value is negative 27 over 22. Now, again, this is after we've done Gauss-Jordan elimination. And this is called reduced row echelon form. Where not only do I have these 1s with these leading zeros here, but also above my 1s, we have zeros. Well, why do we care? Why is that nice? Well, let's rewrite this as a system of equations. Well, this is now x equals negative 27 over 22. Y equals negative 47 over 44. That's it. It's not even a system of equations. It's just my answers. So reduced row echelon form is awesome. So I know this was a tedious process. I need you to understand the process, but typically we're just going to let a calculator handle this for us. But that's how we're getting here, is we're multiplying these rows, we're adding them to other rows, and that's how we're doing this form of elimination. It's the same stuff we were doing before. We've just taken the coefficients away. So that's how we do that.